get started. But yeah, we're gonna try to get this out. We're gonna try to build a portfolio project for boot.dev in C. Okay. So we got the stream started. Let's see. We've got the doing set. We've got our Twitch link pinned. Stream seems like it's doing okay. I think all the housekeeping is out of the way. Got our music. The Discord has been alerted. Okay. Let's go ahead and try to dive in here. So I think first things first, we need to set up a local C development environment, which I don't have. I've never written any C outside of a browser before. So let's go ahead and see. We need a compiler, obviously. I think I have GCC installed on this machine. Okay, so I do have GCC. But I think for NeoVim, I'm gonna need something else. To the browser. To the browser. Let's see, NeoVim, CLSP on Windows. There we go, that's better. Okay. I guess let's start with mvim lsp config. And let's figure out what we need to do here. So, chasmy update. Is that actually up to date? Yep. Huh. I don't feel like it is. Something's off, right? I'll fix that. Yeah, I haven't pushed that up. Okay. What am I trying to do? I need to set up a place where I can write C code. So let's go ahead and cd into repositories. Let's make a dir. Um, I think I'm gonna call it. Let's see. Let's just call it chip. Let's make a dir called chip. cd in there. I'm guessing I can throw item. Not. Hey, what's up, 199? Long time no see. How you been? How's life treating you? Oh, damn, the ads got you. Sorry about that. Yeah, it has been a while. Hope you're doing well. So let's do main.c. And let's just go ahead and try to write our first little hello world. So we need int main, something like that. And I guess we can do return 0. And let's just try to print hello world. So we'll do include standard, is it io.h? And do you need to send me there? I don't know if you need to send me there. And then we'll do print f hello world, like that. Life is good? Well, that's lovely to hear. I'm glad, man. I'm glad. I'm always rooting for people, you know? Okay, cd into chip. Chip. And let's go ahead and see if we can figure out how to compile this. So I have GCC. So how do I do this? Options in the file. So let's just start with, I guess, no options. Pass it main.c and see if it compiles. It does. So then we can do, cool. I guess what I'm gonna do is I'm gonna go ahead and or actually not make dir. Hey, what's up, Oblivion? Yes, we're gonna try to do some coding today. We have to build a portfolio project so we can move on in boot.dev. So I've picked a kind of, I guess from what my research tells me, this is kind of a classic beginner C project. We shall see how it goes. I might abandon it because some of it seems way over my head, but I'm gonna give it my best shot. Okay. I think what I'm going to go ahead and do is I'm just going to make a little run.ps1 script. And this was in here, I'm just going to say main.c for now. And I'm guessing there's other arguments I'll need to add to this, but let's see, run. Or, sorry, let's remove this guy. Let's run. Okay, so that works. Now we need to do a little bit of Yes, learning C for fun. Yeah, we're learning C because we're doing boot.dev. So you can kind of basically think as the next few streams is just an extension of boot.dev. It's just we have to build our own projects to move forward. They let you do the portfolio project in whatever language you want for the most part, I think. Um, but I thought it would be nice to challenge myself with uh, what do you call it? Challenge myself with a C project. Sorry, it's early. I have not had enough caffeine. We'll see how it goes. I'm definitely a noob when it comes to let's see, let's call this main.exe, or no, let's call this chip.exe, and we want to run that, and then we want to say if, what is it, last exit code? I think it's last exit code. Yeah, it's last exit code. So remove A. So we want to basically say if the last exit code was not, does not equal 0, we want to write post failed to compile and otherwise, and then I guess exit. Otherwise, we'll say write host compiled successfully. And then I'll just write a little message here that says post compiling. Oh, yep, I'm in PowerShell. So how do I do, what is it, equals? We have to do like an equal operator. Equals. Is there a not equals? God, it's been so long since I've written any PowerShell. PowerShell not equal. -ne. Okay, and then compiled successfully, otherwise we'll print that it failed. And then I want to actually run it, right? Post running and then we'll call chip.exe. Hopefully do something in there useful. Check out the project's Discord. I just posted something in there. Okay, good to see you, D. Hope you're doing well. See, I recently released this project. It's an ASR model for transcribing Ghanaian languages. It's Soda for open models. Nice, dude. Little hugging face. Very cool. It's way over my head, but that's very cool. I realized how much effort and work and complexity probably went into doing that. So kudos to you, man. Kudos to you. gonna do, I am gonna write a little, give myself a, oops. I don't like that. Don't like the look of that. So let's just add the new line between this. Okay, so we're basically going to build what amounts to kind of a emulator of sorts, as I understand it. So basically a way to mimic hardware and instruction sets in a very small model. My understanding is that this is a very well-known project. Lots of people have built it. So what I'm going to try to do is I'm going to try to do my best to avoid basically basically having a large language model just dump out the solution, because I know that that large language models have likely seen the solution a bunch of times. So there's a specification, I guess, out there that's very famous that people used to do this, called CalGod's CHIP-8 technical reference. I think this is the one. And this basically tells you how it should be done. So I'm going to go ahead and convert this to some Markdown. Let's see. Markdown. Web page to Markdown converter. Yeah, let's do this. I'm just going to save that alongside our project. What? Why did it time out? Okay, well, we could just do HTML then. Huh, that's interesting. I guess maybe because it's HTTP. Let's see. HTML to Markdown converter. So let's go ahead and get the HTML. So we will say curl. Oh, there we go. I've done it before. So let's do spec.html. Let's just make a directory called docs. We'll move the sec in there. And then let's go ahead and cat c docs spec. Don't want your ad. Oh, dang it. Copy that. Go back over here. Anyways. Alright, so this is our table of contents here. Let's go ahead and toggle on word wrap for ourselves. Of course, D. Yeah, man, I can always appreciate somebody's side project, dude. Or maybe it's your main project. I don't wanna belittle it by calling it just your side project, because it looked like a lot of work went into it. All right, so how to use this document. While creating this document, I took every effort to try to make it easy to read, as well as easy to find what you're looking for. In most cases where a hexadecimal value is given, it is formed by the equivalent decimal value in parentheses. For example, 0x200 is 512. Well, that's nice. In most cases, when a word or letter is italicized, it is referring to a variable name. For example, if I write v underscore x underscore, the x refers to a 4-bit value. The most important thing to remember as you read this document is that every link will take you to the table of contents. Also, links that you have not yet visited will appear blue, while links you have used will be gray. All right, so about CHIP-8. Whenever I mention to someone that I'm writing a CHIP-8 interpreter, the response is always the same. What's a CHIP-8? CHIP-8 is a simple interpreted programming language, which was first used on some do-it-yourself computer systems in the late 1970s, early 1980s. The Cosmac VIP, Dream 6800, and ETI 660 computers are few examples. Excuse me. Is the stream muted? Uh-oh. Hello, hello? Come in. Very original, unoriginal idea. Let's see. The interpreter. Where are we? Where was I? These computers typically were designed to use a television as a display and had between 1 and 4K of RAM. They used a 16-key hexadecimal keypad for input. Oh, that's interesting. So there was literally like A, B, C, D, E, F, right? Are those the hexadecimal letters? I think those are hexadecimal letters. The interpreter took up only 512 bytes of memory, and programs which were entered into the computer in hexadecimal were even smaller. In the early 1990s, the CHIP-8 language was received by a man named Andreas Gustafsson. He created a CHIP-8 interpreter for the HP 48 graphing calculator called CHIP-48. The HP 48 was lacking a way to easily make each game at the time, and the CHIP-8 was the answer. CHIP-48 later begat Super CHIP-48, a modification of CHIP-48, which allowed higher resolution graphics. I wonder when they say higher resolution, I wonder what they mean by that, as well as other graphical enhancements. I'm sure it's actually not that high compared to today's standards, but probably then it was a significant improvement. 110 and A through F. Yeah, A, B, yeah, okay. CHIP-48 inspired a whole new crop of CHIP-8 interpreters for various platforms, including MS-DOS, Windows, the Amiga, HP-48, so on and so forth. I became involved with CHIP-8 after stumbling upon Paul Robson's interpreter on the World Wide Web. Shortly after that, began writing my own CHIP-8 interpreter. This documentation is a compilation of all 3 different sources of information I used while programming my interpreter. The section describes the CHIP-8 memory. This section describes the CHIP-8 memory registers, display keyboard, and timers. Okay, so the CHIP-8 language is capable of accessing up to 4 kilobytes or 4,096 bytes of RAM from location 0 to 4,095. The first 512 bytes from 0 to somewhere. What number is this in hexadecimal? I'm not good with hexadecimal or binary, so this is going to be quite an interesting project. So this is what to what? There's probably some little utility I can use to quickly convert stuff. Hexadecimal to base 10. This would be 155. So that would be what, 511? So 5111. So the first 512 bytes. Oh, LOL. I could have just inferred that from it being from the start of the sentence. Are where the original interpreter was located and could not be used by programs. Most CHIP-8 programs start at that memory location, but some begin at 1536. Programs beginning at 1536 are intended for the ETI 660 computer. Okay, I guess we don't need to worry about those then. So here's what it looks like laid out in memory. So this is your program. This is for some other type of, I guess, machine. Then you have the start of your program here. Okay, interesting. All right, so now we need to, I guess, well, I don't know. Do I need to read the whole spec, or should I kind of break this down, I guess? So that's talking about the display. This is talking about binary. Maybe Markdown wasn't the best way to view this. Maybe I should be looking at this as a HTML file. Let's do node. With the skill you are currently acquiring, what do you wish to accomplish? Just have fun. Yeah, just have fun and learn and challenge myself and try to have a good time. I've got an oddly useful skill of guessing any color I see in RGB hex. Dude, that's impressive. We should get you to train that skill. Yes, we should. I think I'm gonna have to. I think I'm gonna have to work on my bitwise operations for this to work. Why didn't that work? Live server. Oh, because I didn't use the right flag. Okay. What the hell? What the hell? Let's see, port open. Entry file. Why does entry file not work though? I guess let's try open. I'm not sure which one will work. I just want to serve this damn local HTML file. Oh, because it's I know why. Whoopsies. This is because the port 8080 is already in use. So this needs to be something random. Okay, I guess that one's in use too. Oh no, it didn't actually set that port. So how do I set the port? I have to use equals. There we go. Now it's working. Oh yeah, that's much better. There's tables. Although the white is a little blinding. Should be able to fix that though. Let's make it dark mode. This is our head. Why is this all in caps? This is our head. So we should be able to go in here and just say, oh, I have it right here. Let's just swap these. Text is going to be, I don't know how this is going to look, but okay, yeah, that's better. It's not flashbanging me so much. So where were we? We were reading about the registers. So CHIP-8 has 16. Hey, Amanian, how's it going? Good to see you. I can't learn anything purely for fun. Oh, that's too bad. Most of the things that I've been, most of the things that have brought me the most joy in life have been stuff that I've just done because I wanted to do them, you know? But that's, I mean, to each his own, right? Like, we all have different motivations. Okay, CHIP-8 has 16 general purpose 8-bit registers, generally referred to as VX, where X is a hexadecimal digit. There's also a 16-bit register called I. This register is generally used to store memory addresses, so only the lowest rightmost 12 bits are usually used. The VF register should not be used by any program as it is used as a flag by some instructions. CHIP-8 also has two special purpose 8-bit registers for the delay and sound timers, okay? When these registers are non-zero, they are automatically decremented at a rate of 60 hertz. See section 2.5 for more information. There are also some pseudo registers which are not accessible from CHIP-8 programs. The program counter should be 16-bit and is used to store the currently executing address. The stack pointer can be 8-bit. It is used to point to the topmost level of the stack. The stack is an array of 16 16-bit values used to store the address that the interpreter should return to when finished with the subroutine. CHIP-8 allows for up to 16 levels of nested subroutines. And there's your keyboard, which we'll have to figure out. And then display. I don't even know how to make a display in C. Go figure. That's something we'll have to Google that. I've heard of people talk about using something called Raylib, I think, before. But I have no idea how to use it. Programs may also refer to a group of sprites representing the hexadecimal digits 0 through F. These sprites are 5 bytes long or 8 by 5 pixels. The data should be stored in the interpreter area of CHIP-8 memory. Below is a listing of each character's bytes in binary and hexadecimal. Okay. Here's our instruction set. The original implementation of the CHIP-8 language includes 36 different instructions, including math, graphics, and flow control functions. Super CHIP-48 added an additional 10 instructions for a total of 46. So all instructions are 2 bytes long. So that's, what is that? That's 16 bits and are stored most significant byte first. Okay. In memory, the first byte of each instruction should be located at an even address. If a program includes sprite data, it should be padded so any instructions following it will be properly situated in RAM. This document does not yet contain descriptions of the Super CHIP-48 instructions. They are, however, listed below. In these listings, the following variables are used. We have in, or adder, or I guess address. This is a 12-bit value, the lowest 12 bits of the instruction. in or nibble a 4-bit value, the lowest 4 bits of the instruction. X and Y, let's see, a 4-bit value, the lower 4 bits of the high byte of the instruction. Y, a 4-bit value, the upper 4 bits of the low byte of the instruction. And KK, an 8-bit value, the lowest 8 bits. So basically, we're going to read this binary. We're going to read this binary file, and this file is going to contain, what did it say? 2-byte instructions that we basically have to parse. And then this looks like this is the instructions we have to implement. So jump to a machine code. Clear the display. Return from a subroutine. Okay. The interpreter sets the program counter to in. So these are the variables up above. That's what this is. So one, I guess, is referring to this. And XKK is referring to this, and X. Skip next instructions if, I guess, the register value at X equals KK. Dude, this is really outside my comfort zone looking at this stuff. But I think it's gonna be possible, because I think for the most part we just have to implement against this spec. It looks like there's some reference. We might be able to track down some of these references, some of these referenced implementations. Okay, so first things first. We have to figure out how to read and open a file in C. I don't know how to do that, so that's probably the first thing we should do, and then we'll just kind of break the problem down into small, manageable chunks, because otherwise this is just too overwhelming, right, to do in one go. So I think the best thing to do is, whenever you feel overwhelmed, make a list. This seems kind of, it does seem kind of, it's definitely outside of my comfort zone. It's definitely beyond anything I've ever done before. But this is I guess what you do with this is the kind of stuff you do with C, I guess. So we'll see how this goes. It's entirely possible I just get frustrated and I throw my hands up and I say, "Fuck it, I'm done. I quit."
Did we just become best friends?
Pop 4K. Pop 4K. I think that's how you say your username. Thank you for the follow. That was very kind of you. I don't have very many people following me over there on Twitch, so always happy to have another person. Okay, so let's try to do two things to start with. To-dos. So first thing is, let's try to read a file. And even better if we could figure out how to I guess even better would be if we could figure out how to read a file based on a relative path, or read a file based on an absolute path. We need to take the contents of that file and store them, store contents of file in memory, right? And then I think it would be really good if we could figure out how to print. I'm actually going to say parse the parse a binary CHIP-8 file. There's a file I saw that's pretty well known, I guess, that people usually try to print. It's the IBM logo. See if I can find it. CHIP-8 IBM logo. Yeah, so let's try to yes, this is a binary file. So I guess let's also make a directory, and let's do maker, what do you want to call it? Maybe test files. And we'll just go ahead and move OneDrive, desktop, IBM logo, move that into test files, like that. So it's a binary file. So let's also make a, I'm gonna go into test file, or let's just do cat, or I guess echo hello world. That's probably actually the simplest thing we could do. So yeah, so let's read a file, print file contents, and then I'm gonna say if we're really good, we can put this all together. Parse individual instructions from binary CHIP-8 file, print instructions. So those I think would be all good milestones to see if we could hit, because then once we are able to read a file and parse the instructions, then I think the bigger hurdle is, oh god, there we go, that's the one on. I think the bigger hurdle is then implementing each instruction. We have to figure out how to do the display, where it sounds like we're going to have a couple different loops happening. We got to have a loop for the inputs, a loop for the timers. Yeah, this is overwhelming, but just break it. We're just gonna do what we do with hard problems or overwhelming problems. We just got to break it down into small, manageable chunks, and then solve the individual problems and just put them together. Okay. So how do we read a file in C? Yep. How to read a file in C. Hey, what's up, 199? Good to see you again. All right, I'm trying to avoid LLM specifically. So let's go ahead and read some documentation. Dude, this is I'm a dark mode. Okay, read a file. So we have a file type. This is a pointer. Open a file in read mode. Yeah, that's what I want. Store the content of the file. Okay, now we can print the string, which will output the content of the file. Okay, what about, does F open in, so F open in C, do we need an include statement? Nope, just standard IO. Okay. Well, I guess we do need one, but I already have it. All right, so first things first. Nope, nope, that's the executable. Um, oh, actually, here's another thing we want to do. Let's do this first. How to capture arguments passed to a C program. I don't know how to do that either. Capture arguments passed to a C program. Okay, an integer that tracks the total number of arguments. You must include two parameters inside your main function, int argc and int argv. Okay. Seems helpful. Seems helpful. So maybe we'll put our notes here as we go through this. So to do this, we have to do int main int argc character char star and then what do I want to say here? Do stuff with the args. Argc is the, what is it? Argc is the total number of arguments passed. It's always at least one because the first argument is always the name or path of the program itself. So argc is number of args passed. Argc is always one or more. Argc always has path name, I guess, name / path of program as first. So that's similar to a lot of other languages that we've written or that I've written. So let's go ahead and declare that for our usage. So we'll say int argc and then char star argv, like that. And so we know we want our program to accept the path to the thing we want to load. So we should be able to do something like check to make sure we got a second argument. We expect that second argument to be the path to the file we want to load into memory. Ideally, we can validate its existence, and ideally, we can handle relative and absolute paths. Okay4 was watching on YouTube, jumped in here. Good luck with this. I'll follow this thing very closely. Oh, nice. Yeah, you're welcome to hang out, come and go as much as you like. We'll see how this goes. Full disclosure, I'm way outside my comfort zone. I've written like all of 3 days of C. I've never written C outside of a browser to this point, so just complete noob when it comes to C programming. So I'm just going to try to use my existing knowledge of programming, the specification. I'm going to use Google search. I'm going to try to limit the large language model use because I know the large language models will just solve it for me, which is not what I want. So we'll see how that goes. All right, so first things first, we should check to see if argc is greater than or equal to 2. Or I guess we should check to see if it's less than 2. If it is, then we should print something here to tell the user you fucked up. You fucked up, bro. We need a file to load into memory. Right? So usage would be something like printf chip.exe file to load. So let's see if that works now. Oh, we should probably return a particular status code, right? So we could probably do. We could probably have like a. This is how I do in other languages, right? I'd have a. Let's see. I'd have a type def enum exit codes. Do I have an LSP? I don't think I have an LSP. I just realized that. Maybe I shouldn't have an LSP. Maybe I should just do this without an LSP. Maybe that would be good for me. And then I guess file missing would be one of my exit codes, but we'd want to start at 1 because 0 would be success, which I guess we could add. 6 completed successfully or something. So yeah, we could do that, and then I don't know if this is something C programmers do, but completed successfully. Run. Oh, I forgot semis. Let's see. Completed successfully is undeclared. Expected expression before. What have I done wrong? Useless storage class specifier and empty declaration. That's line 6. Oh, this? Expected semi-identifier before int. Am I not defining an enum correctly? Define enum. Hey, what's up, Dota? Have you written any functions of functions? Mallet, pointer, passing confuse me a lot. I'm so early on in my C adventure. Everything that you ask me if I've done it, the answer is probably I have not done it. Okay. Completed is oh, I didn't spell it right. But so far I'm having fun. This is what it looks like when you're learning something new, you know, you just Painfully trying to make it work. Line 18, expected expression before token. Line 18. Oh, this should be file missing. Or actually, I guess a better one would be file not provided. Because file missing kind of is a different thing. There we go. You fucked up, bro. We need the file to load into memory. So this is where we have to remember to print new lines. Okay, so that works. So if we do give you a file path, though, I would assume we get through that successfully. So if I do, oh, I guess I have to figure out how to pass that through. So I want to pass arguments through to chip. So PowerShell pass arguments. Okay, so this would be param string $. We're gonna do file. It's not gonna have a default. And then we're gonna pass that to here. If you don't, oh, I don't even have to do that. So we'll just do $, or $args 0. Oh, so we would do test files and then hello world.txt. Cool. So I guess that's so our first to do, let's give ourselves a little dopamine. We accomplished this guy. Now we need to figure out how to read a file. So we know we have to use fopen. Yeah, fopen. And what else? We know, let's see, does C have a way? C. Determining if path is relative or absolute. So we also need a way. Well, I guess, do we worry? I guess we're just going to worry about this working on, I guess, Windows and Linux, I guess. Because they're going to have different path separators. Let's not worry about that, Stephen. Let's not do that just yet. We're going to head ourselves. Let's just read the damn file. Let's just read the damn file. Okay, so assuming we got this far, we have a file. So we're going to get a file file, this is star file pointer equals f open, and we pass in the file name, which will be I don't know. I guess I actually don't know. Let's print the file name we were given. How about that? Before we open it. Print file name given. So this would be something like char star file path, I guess we'll assume file path equals argv at arg, or I guess we can just hard code this to be 1. And then can we do printf file path like this? And I guess we could actually do loading file at okay. Initialization of char star from char makes pointer from integer without a cast. So let's do that. That didn't seem like it did what it's supposed to do. So now we need to get basically need to figure out how do we get the argv value. Hey, what's up, Gosslayer? How do you plan actually how to build something? So I basically, in this case, I just stumble through it. You know, like, sorry, I didn't mean to ignore your question. So we have a spec. This is a spec that somebody helped kind of draft of how you build one of these emulators. And so we've basically read like the first 2 or 3 sections. And based on my initial reading, I know I need to be able to read a file into memory. I don't know how to do that in C, so I basically just kind of started writing down to some to. If I try to look at it all and think about doing it all at once and figure, I'm gonna get overwhelmed and I'm gonna give up. So I'm just trying to break it down into small, manageable things that I can sort out and figure out and check off the list, and then hopefully I'll at some point I'll have solved enough little pieces of the puzzle that I'll be able to put it all together to make the final thing. So my approach is a very kind of plodding engineer approach. It's not I'm not a genius. I just like I know some people probably could read that specification in one go and implement it all in an hour. And unfortunately, for whatever reason, God did not gift me with that ability, but He did give me the ability to stick with a problem and persist and struggle and eventually figure things out. And so that's the superpower that I try to apply. Oh, did Twitch go down? Twitch, are you back? Sorry. Sometimes my internet's not very cooperative. Dota, how do you answer the common manager question? Why aren't we going faster? Or other variants like, are we there yet? Typically, so this is just even outside of programming in general. This is more of like a project management question. Typically, I just ask, how fast would you like us to go? Like, this is how quickly we're going now. How quickly what would be ideal? And then I just try to present the facts as like, here's what we've been asked to do. Here's how long it takes to accomplish that task. If we want to get it done faster, then we need to actually make a plan or implement changes to the process or the deliverable to achieve it faster. Like you can't just I think what happens is if you get stuck just arguing somebody's expectation in their head, it's not very productive. You have to bring the conversation to like brass tacks, like facts, reality, data, and have a conversation about that. Um, because if you're just sitting there arguing about two people's expectations, it's not very useful. So I usually just try to have an honest conversation that's grounded in, well, the last time we did XYZ, it took us this many weeks or this many days, and if we don't change anything about the way we do XYZ, it's going to take that many days, right? Um, I think it's just too many people don't have conversations that are grounded in like the actual facts of reality. There's too many conversations that are based on people's vibes. Like, we're not moving fast enough. Okay, why do you think we're not moving fast enough? Oh, I'm back. Yes. Sorry for the internet falling down on me. I've never really hit the deadlines, and more planning just highlights that. Uh oh. Well, I think that's a question only you can answer, which is, are the deadlines unrealistic, or is your planning bad, or is there stuff that you need to do to change your, like, you know what I mean? Like, you have to have an honest conversation. Are the deadlines realistic, or are the deadlines unrealistic? And then based on that, that kind of drives what the next step is. Um, we have planning 3+ months out. Nice. So I would just want to know, like, what is your planning process? How do they decide what happens when and how much time things take? Are they grounding that in actual data that they've collected? Do they have a like an IMR chart? Do they have an actual process chart that shows that it every time we do XYZ feature or bug or this amount of work, it takes this amount of time, right? Like, if people are just if people are just throwing shit on a spreadsheet on a dashboard without it being grounded in any like historical data or trends, there's not a lot you can do there. Me and the other developers made the plan, set the story points and scopes. So you guys, I think that I think that comes down, if you guys are in charge of all that, it comes down to you guys tracking the data and analyzing the data. So if you make a plan for a month or 3 months or whatever it is, you make a plan, and then at the end of that plan, y'all need to sit there and look at, this is what we estimated, this is how much it took, right? And you've got to figure out what's the delta. Did it take longer? Did it take less time? Why did it take longer? Why did it take less time? And then you need to bring that feedback forward into your next cycle and say, oh, whenever we do XYZ thing or we work on this particular aspect of the code base, our estimates are always short by 10% or they're long by 10%. And you need to make sure you're bringing that forward. Otherwise, you don't have a good feedback loop, right? You're just always going to be wrong. Your estimates are always going to be off. Your project timelines are always going to be poor, because you should be able to collect enough data that you can make, you can make basically uh, I'm very passionate about this stuff because I did project management for like 6 years for a very large frozen food manufacturer when I was a food scientist. So you should theoretically be able to break it down that like a given thing takes you a given number of story points or a given number of time plus or minus some standard deviation. Well, the estimates may or may not be right or wrong, but you won't know unless you track the data. So you have to track the data. Like, estimates are an approximation, but you have to you guys have to be able to over time figure out, like, every time we do this type of task or this type of project, right? And you guys can arbitrarily decide how you want to categorize and slice it, but you should be able to bucket over time how much, like just arbitrarily tracking and measuring, right? The median time for this task is X. The standard deviation is this, which means if the process is reasonably normally distributed, we should complete that task within this time frame 95% of the time, right? You can even assign some sort of confidence interval to it. It's possible, but it takes discipline, it takes time and effort. You actually have to collect the data, review the data, analyze the data, and then bring those conclusions and those findings into the next cycle. And I think most of the time teams are very bad at doing that work. Nobody wants to do it. It's kind of boring. It's not fun. Yeah, you can use a burn down chart. I mean, it's just statistical process management. That's basically what it is. It's the same stuff people do in manufacturing, in project management for large construction companies. Like this is a solved issue in a lot of industries, but for some reason, for some reason in software development, uh, it continues to be we make it way more complicated than it needs to be. We have all these crazy measurement systems and systems of units that are proxies for other units of measurement, and we've got weird terms and words for different. It's like it's not that deep, man. It's not that deep. You need to track your time, do an analysis, figure out how your data is distributed, um, and then do what everybody does with statistics, which is make a projection and assign some level of confidence to it, and do that over a long period of time. I mean, I don't think you guys are. I don't think it doesn't sound like your situation is unique, though. I think that's a problem in a lot of teams. You know. Hey, what's up, Mark? Good to see you. Hope you're doing well. Okay. So now what we're gonna do. Thank you for holding it down for us over there, Mark. Oh yeah, the questions bit was generic on purpose. I've been asked a lot. Yeah. I think the answer is you got to track and analyze your process. Um, but I think way too many people that is difficult. Tracking and analyzing your process and managing your process is difficult, and it's not fun. So a lot of people just prefer to manage off of vibes. Let's just go based off of vibes. This feels hard. This feels like it will take a long time. I don't know. I don't think that should take that long. Like it's all just it's all perception. It's all vibes, and I mean it's one way to do it. You Mark, getting hype up, planning on learning Rust. Nice. I think Rust is a good language. I think it's a good language. Okay, so we do F read. We pass in our file path, and then we have to tell it what mode we want. We have to tell it read mode. Let's see. How to print argument value. That's where the numbers come from. A general knowledge of how long it takes to go from I wrote code to it's in production. We look at the code, what it should change to, or how it should be built. I think that's good. Yeah, that's the first step, right? And then, but you have to do that historically over time. Um, yeah, but there shouldn't be just a general knowledge. You should know. You should be able to look at tasks, historical tasks that say like, well, when we built this feature, right? When we built this feature, it took us this long, right? And then over time, you should be able to hopefully bucket features relatively, like, you know, adding a page took us this long, right? You should be able to bucket tasks or bucket features together, right? Based on relative scope or parts of the system they touch. And so then over time, you should be able to historically look back and reflect and say, yeah, it took us roughly this time. This is what we usually average. This was the actual time it took, right? And then if you can get to an average or a mean, then you should be able to get to a standard deviation. And if you can get to a standard deviation, you should be able to run a Monte Carlo or just do a rough normal distribution curve to say if something took, let's say something took 2 weeks or three, let's say it took 3 weeks and it has a standard deviation of completion time of half a week, then you know that task on average will take 95% confidence. You can say it will take from 3 standard deviations away from 3 weeks to more than 3 standard deviations away from 3 weeks. And if that estimate is not acceptable for your team, well, then you have to start having conversations about, well, what do we do? What kind of process changes or what kind of things can we do differently to make that time shorter? Yeah. It's work. It takes diligent work, and it really requires somebody's full-time job, or at least a big portion of their job has to be project management and process management and keeping an eye on the data and talking about the data and reviewing the data at every planning meeting and keeping it up to date. Like it's discipline and it's boring work, and no one wants to do it. But that's what that's what good project management is about. I really hope I could use it to make a desktop app or mobile app. Rust frameworks out there. So I've used two, Mark. I am currently using Tari, which is uh, it's kind of like a Electron, but for Rust. So if you want to build native apps, you can use Tari. This has actually been really fun to work with. Really enjoyed it, but I'm also kind of a web developer person, so take that for what it's worth. And then the other one I used was called iced.rs. It is a pretty site, isn't it? Yeah, they did a good job. So this is my current side project. This is what I'm using as Tari. Iced RS though was the first thing I used, and this is purely a Rust GUI. There is no CSS, no JavaScript, no web technology. It's all Rust. You write everything in Rust. The GUI is written in Rust. The states in Rust. The events are in Rust. All of it's Rust. So if you'd be interested in doing something like that, this is the one I have experience with, and I had a good time. Um, I think I like Tari or Tori. I don't know how to say this word. Uh, I like this better just because I have more comfortability with building UIs with web technologies. Uh, so take that, I think, kind of as a grain of salt. Hello, Teo. Nice to see you. Tari. Tari. I thought iced was a thing you do with those ice coolers. Well, in this case, it's a Rust GUI library. It's a Rust GUI library in this case. All right, so how do we do this? We have a char star pointer, right? Um, so I guess let's actually just do for int I equals 0, I plus plus, I is less than argc. Whoops. I wrote that out of order. I is less than argc, I plus plus, and then I think we could just do printf arg and then %C. And argv at I. Let's see what that does. Interesting. So it looks like we have two args, but what they are is not, I guess, what I would think they would be. Let's see. Print S, what does that do? That prints nothing. Okay, we're off to Google now. Let's see, C. How to print char star. Oh shit, this should be an array. Whoopsies. Whoopsies. That's my fault. That's my fault. This should be char star. So I did have this typed correctly the first time. I had the signature of the method incorrect.
MRK_Manansala is reminding you to hydrate.
Ah, damn, I have my water. Hold on, one sec. I printed it. I printed the args. Okay. Didn't expect to not have it. That's my bad. Yeah, I should have had it. Hey, what's up, Kale? Nice to see you. Thanks for being a member, man. Appreciate you. I made a mistake and it was because of AI today. Damn. AI slop cannon, I trusted it too much. Ah, I'm sorry, dude. They got me to make a report primarily using AI. Then got at me because it was incorrect. Ah, I'm sorry, man. I'm sorry. That's the dangerous thing about AI, right? It can give you this false sense of confidence. Tyler, petition for you to learn assembly next? Dude, I can't figure out how to print strings in C, okay? Assembly will probably take me out forever. I might never come back. It's fine, it's my second day. I mean, mistakes happen, though. You can't beat yourself up too much. They happen. Okay, I'm gonna try to declare a new function. How do you? I don't think I've ever written a function in C. So I don't have to actually do that. I can just do void print f in, and this is gonna take a string, which I guess would be char star s, and then all it's gonna do is it's gonna do this, where see if this works. Previous implicit declaration of printfn with type void character. Did you mean printfn? No, I want to use my actual function that appends a new line. What's that warning telling me? Implicit declaration. Implicit. Oh, dude, this is the Google implicit declaration of function. Oh, because I put it below. So we actually need to move this up, don't we? Let me put this up here. Too many arguments to function print fn. Note declared here. Oh yeah, okay, so how would I do that? So what is the signature of print fn? Print fn signature C. Format specifiers args. So how do you say args? How do you do C remaining args? Oh no, my browser is slowing down. When you said signature, what is the meaning of that? Sorry, I only touched C++ only for a few days, never looked back in. No, when I say signature, I just mean like your typical, oh, whoops, I killed the music. When I say signature, I basically just mean like, what does this method return and what my, I'm going to bring my browser over by chat so I can actually see you guys while I'm searching the web. Hello, Stephen. How are you doing today? Hope you're having a wonderful day. I'm doing well. I'm currently struggling through learning how to write a program in C. It's going fairly well. I haven't crashed anything quite yet. But yeah, we're having a good time. Got my coffee cup is almost empty though, so we're gonna have to fix that here in a couple minutes. So far, I've successfully learned how to accept arguments to my program.
MRK_Manansala is telling you to drink some coffee.
Thank you, Mark. Appreciate you. Yes, coffee cam. Yep. So far, I figured out how to successfully get arguments into my program, as well as print those arguments. Now I'm trying to figure out how to load a file and read it into memory. So that's the next thing. So currently I'm searching for print f define function with remaining args. I don't know how to do that. Let's see. So you just literally type dot dot dot. Okay. So this would be this is our format. And then this is the remainder. And then we can say args and format like this. Okay, undeclared. Oh, so I bet args has to come from somewhere. So how do we get, let's see, C, variadic arguments, how to initialize. I'm trying to avoid using AI for this. I'm trying to just search and read documentation so that I actually am kind of forced to understand. So the way this works is I have to say, I have to do includes here, and I do a standard arg, and then I have to say va list args, and then I have to initialize it with a function called va start args. Whoops, I misspelled that. And then I can use the args at this point. Then I have to say va end args. Right? Yes? No? Maybe? Oh, let me try to run this. I don't know if this actually works. Undeclared. Oh, did I not write that out? Let's see. Macro va start requires 2 arguments, but only given 1. Okay, what's the signature of va start? Hey, what's up, Gun Highs? Damn boy, you're doing fast. CHIP-8 virtual machine. Damn, gotta go fast. Well, I just Googled yesterday like good C programs for beginners or good portfolio C programs, and this one kept coming up over and over again. So I was like, let me try it. Every time I watch you, you're always improving. Well done, man. Yeah, I don't know if I'm improving, but I'm having a good time. Yeah, I'm having a good time. B start, C signature. I mean, the thing is, I have like 19 years of working left, and I've got to figure out some way to pass the time, you know? Let's see, list object that will be initialized to point to the variable arguments last. The name of the last name parameter in the function signature immediately preceding the ellipsis. So we have to do this format. Okay, var end. Implicit declaration of function var end. Did you mean va end? I did mean va end. The compiler's so smart. There we go. Now loading file at, okay, that didn't work though because the file's not, that's not right. So how do we, best program to learn C is to program a two-way linked list. Really? That's the best, you think? I think linked lists are kind of confusing. So I guess I need to spend more time with them. Okay, it looks like there's another method here called v printf that I can use. So v printf, so I can say va list args. That's my list. Va start initializes that list starting from the last named parameter, which I passed in here. Then you can call that. Okay, but how do I get the line? Okay, that's what I want, but I want a new line always printed. Is there a way you can print a single character? Let's see, print single new line character. I guess you can use put char in or the printf function. Okay, so I could actually just do printf like this, and everyone would be happy then. Ah, dang it, semicolon got me again. Yes, that's what I want. Okay. That is exactly what I want. So that feels good. So actually, let's change this to print line. That seems more appropriate than print fn. That's kind of confusing. So now we have a little helper function. We'll call it print line. Okay, so then we figured this out. To-dos. Yeah, this is just print f %s and then whatever thing you want to get from argv, 1. A little bit more dopamine, check off something on the box, keep yourself motivated. We're actually making progress. Now let's do the big thing, read a file, yeah? So, assuming we have a file path, we're going to do file pointer equals f open. We give it our file path and then the mode, which is R, I think. Okay, that didn't break anything. Or I don't think it did. Yeah, didn't break anything. So now we need to actually load that into memory and actually get the content. So how do we file C read into memory? And specifically for our program, we are going to have, what was it? It was node, sorry, MPX. It was like 496 bytes of memory, right? Yeah, 4096 bytes. So can we literally just create C read file into memory? Yeah, the semicolon keeps screwing with me. Good to see you, Delusional Dev. Hope you're doing well. Which is funny because normally I write languages that all have semicolons, but I've spent like 2 weeks writing Python. so basically boot.dev kind of, they got me all fucked up. They got me writing Python and they switched me to C. It took me like 3 days to stop writing semicolons at the end of everything. Now we'll see how long it takes me to go back to writing. All right. So I think what would be our concern here, right? So I think right here our concern is, does file exist, right? That's the question we should probably answer. So how do we answer that in C? What does... God, why is my mouse moving so freaking slow? Okay, what does... I'm actually going to go to the C documentation fopen C documentation. Just read it. So we have our R read. We really should make this dark mode. I think I have an extension for that, don't I? Dark. I think there's an extension called Dark Mode Reader. And my mouse is so laggy. Boot.dev surely knows what they're doing. Yeah, I mean, come on, like, give us a break. There we go. That is so much better. God, that thing was I was blinded. Okay. File access mode flag B can optionally be specified to open a file in binary mode. So actually, that might be what I want, huh? Okay, action if file does not exist. It returns null and set error. So we can just check for null. So we can say if file pointer equals null, then we can say return file missing. We'll just add an exit code up here. And we'll just print a message. We'll say file does not exist. This will be our file path still. Say %s. Okay, so let's try to give it a non-existent file now and see if we get that message. So we'll say run, and we'll just change this to hello world.md. Let's see, loading file, md file does not exist. Wonderful. Now, if the file does exist, we should load it into memory. Now, how do we do that? Hey, what's up, Bradley? So what's the go here? We execute some other system instructions, also what compiler to use. So please take everything I say about C with a very small grain of salt because I don't know anything I'm talking about. I've never written C before. I'm 3 days into it. I am using GCC. That's what I have installed on my machine. That's what I put there so that I could make things play nice in NeoVim. Because you got to have a C compiler. If you're working with certain things about NeoVim, I think certain plugins require it. So I'm using GCC. I don't know if that's the right one. I need to add LSP support in NeoVim for C, and apparently to add LSP support, they recommend using something called ClangD, I think is the... and I know Clang is a... Yeah, ClangD is the LSP, and I know Clang is a compiler, right? So I don't really know what the right one is. And if anybody has any suggestions, please feel free to share them. I will not turn them down. Go ahead and lurk, Mark. Appreciate you. I know very little about C. Looks interesting though. Yeah, it is. It is interesting. Yeah, it's. So basically, going back to your other question about what are we trying to do here? We're basically trying to implement this specification, which is basically a emulator for. I mean, it's basically an emulator of a computer, a chipset, hardware. it basically will function as an interpreter at the end of the day. We'll be able to load up CHIP-8 programs and run them essentially. So at kind of the way I understand it is we're basically going to load a binary file into memory. We are going to parse that file, that binary file, into instructions. Each instruction does a particular thing that we have to implement when we see that instruction. And then we also have to figure out how to then render the program to a display. The cool thing is though, like it will actually like people can actually write like small little games that will run on the emulator. So once we hopefully get this working, we should be able to take CHIP-8 programs that other people have written and load them up and actually play them and use them. Full disclosure, this is far beyond my comfort zone. I've never done anything like this, so I'm trying to just kind of stumble my way through it the best I can. Based on Googling, though, and research I did yesterday, there's a ton of resources on this. So, like, if you ask a large language model to make this, it should be able to basically one-shot it because there's a lot of people who have done it before. But I thought it would be a good exercise to help me, one, practice my C, get more comfortable with binary operations, and have a portfolio project for boot.dev, which is what that's currently what that's my main goal, is to become an archmage on boot.dev. And I'm currently going through this step right here, which is building a personal project. And they don't really give you any like specifics. You can basically choose whatever you want. So I chose this. This seemed like more fun than just writing another Python program. Okay. It looks like we can use something called fseek to get the number of bytes. Then we can use something called fread to copy all the text into the buffer. Confirm we have read the file. So I think we want to, okay, let's start with, first, Steven, let's not get ahead of ourselves. Let's just start with reading the text file. So if we have a file pointer, we should be able to say fseek hold on, what's okay, so we should be able to say int num of bytes equals ftell, and that's where we pass in our file pointer. And let's just go ahead and print line, and we'll say file has %d bytes, num of bytes, %s, pass in the file path. Oh, whoops, yeah. Text. See, file hello world.txt has 0 bytes. And why is that? Because ftell, what is ftell signature? ftell. So it takes a file stream. Write array to a file. Read the fp values into an array. Oh, we have to seek to the end. Sorry, I missed that step in the. So we have to seek to the end of the file before we can get the number of bytes. We have to say fseek, which I'm guessing comes from file pointer. And what do we do here? So fseek. COMG, you're building a CHIP-8 emulator? I'm trying to. At this point, I'm just trying to read a file. I'm just trying to read the contents of the file and print the file. So I'm kind of forcing myself to not. I'm trying to force myself to do it in the most friction way of like Googling and reading documentation so that I really have to sort of commit some of this stuff to memory. Okay, the file stream to modify, the offset, number of characters to shift the position relative to origin, and position to offset. How do you... Oh, seek to the end. Yeah, that's what I want. So we want to seek to the end. So 0, and then I guess seek in must be a constant. So we do 0, seek in like this. Now let's see if there's... Has 14 bytes. Wonderful. Wait, isn't this C++? I don't think so. No, this is C. Yeah, this is C. Main.c. Yeah. I'm pretty sure I'm writing C. What is bro doing? I'm trying to build a portfolio project for boot.dev, but I'm doing it in C, and I'm trying to build a small little emulator that will run these things called CHIP-8 programs. And which is basically you're making an interpreter that will parse a file and then run its instructions. This is basically what you're doing. What is CHIP-8? CHIP-8 is a instruction set, an architecture, a specification, I guess a programming language in kind of a way, I guess you would say. I guess a programming language that CHIP-8 is a programming language that you can use to author programs that run on specific kinds of really old computers. There we go. Okay, what Minister of Defense said? A hypothetical game console. Mind showing me some code of CHIP-8? Let me see if I can find some. I have a CHIP-8 file. Let's see, CHIP-8 code. Let's see, that's the AI overview. I mean, I'm guessing you would actually write like just the standard opcodes is what you'd write, either maybe in binary. Let's see, how to write a CHIP-8 program. Are you actually supposed to write building? This is all about emulators. You're actually wanting an actual. Let's see. Each CHIP-8 program. Nope, that's emulator. That's emulator. Maybe Gemini can show us an example. Please show an example of what it would look like to write a CHIP-8 program. Please. Not an emulator. A program that the emulator runs. I'm trying to avoid seeing the code for an emulator. CHIP-8 program should be in its own assembler. See, writing a program in CHIP-8 is very different from writing code in modern programming languages. Because CHIP-8 is a simple virtual machine originally designed in the mid-1970s, it does not have a high-level language like Python or C. Instead, you write programs directly in assembly language using short mnemonics, I don't know how to say that word, which are then compiled into hexadecimal machine code. So there you go. So you'd actually have to write you'd have to write the machine code essentially. But I don't know why can't it show me, oh, the assembly code. Here's an example of assembly code. There you go. That's probably helpful. So our job, or like my job though, or what I'm trying to build, the project that I'm trying to work on is basically being able to interpret that, right? So that's where the parsing of a binary file, the bitwise operations, processing the opcodes and executing each specific instruction. That's basically what we're building, or I'm trying to build. Whether or not I succeed, we will find out. Oh, you probably can't see that very well because of my camera. There you go. So hopefully that helps a little bit. We'll have fun with this. Yeah, we'll see. We'll see how it goes. Hopefully at the very least, hopefully I'll be a little bit more comfortable in C when it's all said and done. All right. So if I know the number of bytes, theoretically, I think what I could do is I could create a buffer to read this into. I don't know what the type would be, but let's say I have a buffer malloc, and malloc needs the size of a char, and this would be the num of bytes, right? And then I guess I should probably just make sure I call free on the buffer down here. But while I'm in between these two things, I should be able to use it. Hello, Slim Shady. How are you? Good to see you. Oh, this should be actually that. So we have num of bytes. We have the size of the char. And then how do I populate that with... So I don't think a void pointer is the right type. I don't know. Like that, maybe? Char. Let's see, copy all the text into the buffer. We have to, so before we do this, we have to do this again. But we're going to seek to the beginning. So seek set. And then it looks like there's a function. It's called fread. fread.
Did we just become best friends?
Hey, thanks for the follow, Lady
Did
of
we
Code.
just become best friends?
Baltic Buffalo, thank you guys. Oh, you rated my channel? That's so nice of you. That's way too kind of you. I don't want to let your viewers down. I don't know what kind of stuff your viewers expect. F read. But thank you very much, Lady of Code. That was very kind of you. F read C documentation. That's what I'm looking for. That's actually the first time I've had anybody ever raid my Twitch channel. So we have the size of each object. So this would be size of char. The number of objects, we know that, and the stream to read. Right? So I think we have all the information we need. So we have, shit, where'd that documentation go? Mother, there you go. No, that's seek. I want F read. I have too many windows open. So buffer. Oh, avoid void pointer at all costs. Thank you, guys. Thank you for alerting me to this. So we have buffer. And then it wants the size of each object in bytes. So that would be size of char. It wants the number of objects to read. So that would be num of bytes. And then it wants the file, the pointer to the file. Okay. So I wonder then, can I move this up here and print the contents now? We shall see. This would be our buffer, right?
Did we just become best friends?
Hey, thank you very much for following the channel, Trash Panda Software. Also, great username. Great username. Way more creative than just using your real name. Let's see. Implicit declaration of function malloc. Include standard lib.h. Oh, that's my bad. I misspelled bytes. And I don't have free because I'm not. Okay, so we need to import standard lib.h and we need to correct our variable name. I'm kind of debating at this point, do I add LSP for C into my editor, or should I just continue to force myself to suffer through writing C like people used to in the old days? I'm kind of on the fence right now. Okay, let's num of bytes. There we go. All right. Too many arguments to function malloc. Oh. We should also, based on what we learned in boo.dev, we should also make sure that this allocation succeeds. So we should check if buffer equals null. We should probably say like memory allocation failure or something like this. And then we'll just print a little message that says failed to allocate memory for file. I don't find LSPs be very useful for C. Oh, really? Okay. I thought maybe it would help with like documentation and stuff like that. Slim Shady, not gonna lie, I thought you were Code with Lewis at first. That's hilarious, Slim Shady, because you're not the first person to say that. Like, you're probably the 10th person to tell me that. I've had people tell me that they subscribed to my channel because they thought I was coding with Lewis. Which is just it's hilarious. I mean, I kind of see the resemblance. Like, if you look at us side by side, I do see the resemblance. Coding with Lewis. Yeah, I mean, I think we have similar face shape, kind of similar eyeballs. We could be related, maybe cousins or something. Did I fix that? Yeah, I fixed it. It worked. So I read a file in, and I printed it to the screen. Okay, that was good. That was good. That was good. Let's give ourselves some dopamine. So this is how we read a file. We're not going to worry about this right now. We're actually going to take that off the table. So this is going to be... I'm actually going to add some stuff here. So let's go ahead and go back to our main.c file. And let's just grab... Let's grab this. I'm guessing these are kind of common file operations that you probably need to know to do. So this is open file in read mode, returns null if doesn't exist. And then this is seeking to end a file can help tell you useful telling number of bytes. Although I would imagine there's maybe a more efficient way to do that. Seeking to beginning a file. And you might say, Stephen, why are you taking notes like this? Because there's documentation. You can always look this up. The main reason I'm doing this is just for my own learning, right? It's kind of like when you're in class and you're listening to a lecture and you take notes by hand. It's kind of that same similar idea where you're just trying to reinforce this new bit of knowledge or this new bit of understanding that you just got. Will you ever refer to the notes? Who knows? But it's just a way of like almost like talking to yourself about the thing that yourself just learned in a way to try to reinforce it. So this is to do, then I'm just going to do that. So get number of bytes. That's good. That's good. This is seek to end a file, or sorry, seek to begin a file. Okay. Now, the thing I'd like to figure out now is what I'd like to be able to do is, since the file that I actually need to load is going to be a binary file, I would like to just treat all files as binary, and then if I wanted to print it out, if I wanted to convert it to text, do that. So I guess what would I do here instead of reading to... How would I do this differently, right? That's the question. I've got to do better with my browser windows. I have way too many browser windows open. So let's make me that my documentation window. Let's close this guy. Let's close that guy. This was something I was referencing. I think we can close that too. This is boot.dev. What was I doing over here? Let's just put these in here. So this is our spec that we're referencing. This is C++ reference code. Hey, what's up, Lady of Code? Hey, I couldn't say anything because you had follower chat on for 2 minutes. New raiders don't have a chance to interact with you, so they'll dip pretty quickly. I stayed around to let you know. Oh, thank you very much. That's very kind of you. Yes, I do have that followers only chat thing enabled. I've never actually been raided before, so this is the first time I've ever really had to think about the consequence of that with a raid. But thank you. It's very kind of you to send your viewers over. I probably let them down a little bit with my content, but it's very kind of you to do that. I appreciate that. So there's a okay. So the first thing I remember is fopen has a binary mode. So how does that change the behavior? Okay. File access mode flag B can optionally be specified to open a file in binary mode. No worries. Good luck with the stream. Thank you very much. I appreciate it. It's very kind of you. Good luck with all your streaming. I hope it's going well. Okay, but on Windows, it disables special handling of new line. On the append file access mode's data is written to the end of the file, regardless of the current position. The behavior is undefined if the mode is not one of the strings listed above. Oh, interesting. Okay, so binary mode is just something that you probably want to have if you're running on Windows, it sounds like. So let's go ahead and add that. But I'm guessing our code should all still work the same. Now, if we were to try to read the actual IBM logo, what would happen? Looks like nothing. It's 132 bytes. So what if I just want to read all the bytes into like a byte array? Let's go ahead and add a. So that's our. Let's go ahead and add a struct. So how we do this? Type def struct CHIP-8, and we'll call this CHIP-8T. I don't even know if that's valid. And here I want to define the memory, right? And our memory is going to be 496 bytes. So let's see. Define a byte array. Oh, I told you guys I was going to do my Google searching over by chat, so I see you guys if you. Define an uninitialized byte array of size 10. Defines and initializes a byte array with specific hex values. So going back to our specification from earlier, so each byte is how many bits? 1 bit. So we want unsigned 8-bit integer, right? Is what we want to be in our array. I don't remember, does C have that? Does C have unsigned int types? Okay, difference between unsigned int and signed int in C. So this is this is the only int that I've worked with so far. Okay, so you can declare something as unsigned here. That's good. So what if I want a specific size though? What if I want an 8-bit integer? C, define an 8-bit integer. Is that something you have to do yourself? Fix with integer types. For each of the following typedef names marked optional, an implementation defines it if and only if the implementation provides a corresponding type. Unsigned type integer with width of exactly n and no padding bits. So I think we want this guy right here. We want 4,096 of these guys, right? You're going to be dealing with unsigned ints more than signed ints in C, especially when building an emulator. Okay, that's good to know. That's good to know. We should probably, I was just thinking as I was looking at chat just now, we should probably go give Lady of Code a follow on Twitch for that raid, shouldn't we? We should be reciprocal. Lady of Code. Oh goodness, there's some scandalous things on the Twitch home. Wow, she's got a big following. 2,900 followers. Dang, dude. She's like the real deal. What kind of programming does she do? Oh, she does 3JS? That's cool. I've always wanted to learn how to do 3JS. That's awesome. I'll have to tune in for one of her streams. That was so kind of her to raid my channel. So what do I have to do? I have to include this in the header of my file. So let's do include what was it? Standard int .h. And then our memory, I guess, is going to be it was uint 8t. Oh, you know what? This kind of makes me second guess my name there. I'm going to do CHIP-8. Okay. So U8, this is going to be our memory. And 496 is our memory size. And I guess we'll just look. Is that how you do that? Declare struct with. God, I keep going to the right to search, and then I'm looking away from chat. An unsigned int 8 is effectively a byte, so this is how you will read a file. Yes, and that's why. So that's why I wanted. That's why I wanted unsigned 8 or an unsigned 8-bit int was because I need exactly, or I'm only allowed to use exactly 4,096 bytes, right? Because a normal int would be 16 bits, correct? My mouse is so laggy this morning. No. So what is a normal int? A normal int is also 8 bytes? Really? Oh, 8 bytes. No. An unsigned int is a byte, right? Because an unsigned int 8 is 1 byte. But it also zeroes value. Sorry, yes, it's a byte. What? Hold on. C. Size of int. The size of an int is typically 4 bytes, or 32 bits. The C standard only guarantees an int must be at least 2 bytes. You don't want, yes, I don't want 0 values. I do not want 0 values. I don't want negative values, right? That's why I don't want the, that's why I want unsigned. Okay, yes, I did this correctly. So we have memory now. So my plan is now, is instead of allocating, yeah. So my plan is now, instead of allocating this random buffer here, I actually want to allocate a do I want to allocate this on the heap? I guess I'll allocate it on the heap. So we'll do chip. And so then this would become size of CHIP-8T. I think that's what I called it. Then it would be if chip failed to allocate memory for chip. Let's see, fread size of. So now instead of reading this into the file, no, instead of reading it into the buffer, I want to read it into the chip's memory. I think this, let's see what happens. So let's do text again. Oh, so this would be chip memory, like that. Let's see, unknown type name uint8t. Did you mean uint8? Yes, I did. Dude, the compiler is actually pretty helpful. People always say that the Rust compiler is crazy helpful. The C compiler is pretty helpful. Maybe it's the version I'm using, but I feel like it's pretty informative on what I fucked up. So I want this guy. Yeah. Oh my goodness, dude. Buffer. Okay, so we have to, instead of freeing the buffer, we want to free the chip. Request for member memory in something not a structure or a union. Request for member memory in something not a structure or a union. What does this mean? What does the, I don't know what that error means. To be fair, what you're doing is simple. It get messier when there are memory leaks. Oh, fun. Yeah. Request for member in something not a structure. Using dot on a pointer instead of the arrow. Oh, forgot to change the type. CHIP-8T. Hey, all right, that works. So that's what I want. I do want to do a check to say how much of the if we go back to our specification, how much of the memory is the program allowed to be? Most CHIP-8 programs start at location 512. The first 512 bytes are where the original interpreter was located and should not be used by programs. So what is this space? This is where I need my hexadecimal converter. So you can go from so the program can go from 512 to 495. So that means at max, the chip program can only be 3,583 bytes. So we could add a validation, couldn't we? And say, trying to think of how to derive that in a constant. Is there a way? I guess we could just define it up above here. We could just define a constant up here that says let's see. Does C have a way to define like file level constants? C. Define file level constants. Constants in C. Yeah, but that's only usable within main. How do I define it? Define preprocessor. Okay, let me look that up. What's that look like? Define actually, hold on. Before we go any further, it's 7 o'clock and I've only had 1 cup of coffee. 1 sec. I'm going to set some water. Boil. Put it in a header. Oh, that's a good idea too. Oh no, my coffee can. It's down. 1 sec. Coffee can. Back. BRB. You know what they say, a watch pot never boils. So, dang. I don't like that that does that. Alright, so you were referencing something called a define preprocessor. I think I need to switch my search engine while I'm doing this because the AI overviews are gonna, I think, steal some of my learnings. So let's go to search. And let's go to this guy, this guy. You gotta go like 7 layers in here. Let's change this to, does DuckDuckGo have? I don't think it does. C define preprocessor directive. Oh no, they have AI overviews too. Jesus. Where do I go? Where do I go to avoid AI just giving me the answer? I don't think any of these will work, will they? Search engine without AI overview. I'm not trying to be a Luddite. I don't want the LLM just being like, here's the answer, right? I want to be forced to have to read and sift through the documentation and do it the way that I learned how to program every other language, you know? Just hang out on C++, that's a good idea. In your browser? Well, what is a search engine that doesn't have AI overview? Because I feel like a search engine would still be useful. Let me set this back to Google then. Oh, turn off AI. Okay, that's actually the right answer, and I'm overcomplicating. Also, thank you very much for being a member, FE911s. It's very nice of you. So you're saying just turn it off. So let's see, Google turn off AI mode or AI overview. Google does not offer an official master switch using web filtering. Oh, you can't turn it off. This is interesting. So this is interesting that we have this dilemma. We can't figure out how to hide from AI. Hold on, I'll be right back. I'm gonna go finish making the coffee, and then we'll figure out how to obscure AI from our view. We need like a learning mode for the browser. Activate learning mode. Use Firefox. That's not a bad idea. I really would like to not change my browser. I mean, I like the suggestion of staying on C++ as the reference. I think that's a great suggestion. However, I know there's going to be times where, out of habit, I search, and so again, it's not the end of the world. I want to get the most out of this experience as I can, because I doubt I'm gonna take the time and effort to write C a whole lot in my life, and so I want this to be a good experience, or good and a useful experience. Let's just search for best search engine without AI. Okay, this is a lie because you have. Oh, perfect. This is perfect. DuckDuckGo with no AI. I wonder why they did that. So they have one that has AI and then they have one that doesn't. It's interesting. Can I set that as my default? I bet I can't. I bet they don't have like custom. Okay, turn this back into an address bar then. Address bar search. See more search engines here. Open a new tab. Oh, interesting. So why can only some of them be used? Make default. So maybe I can make this. So let's go here. Let's test it. Okay, so that's the... Can this just be? Yeah, so let's just do that. Let's just basically, all we have to do is change this. I'm hoping all we have to do is change this to edit. Change this to no AI. Then go back here. Change this back to DuckDuckGo. Okay, now let's see what happens. Let's see if it uses that how to open file in C. Nope, it still used the duck AI off. Anonymous never. Okay, maybe that's a better solution. How to open file in C. Yeah, I think that's the better solution. Well, thank you, DuckDuckGo, for allowing me to change the settings. Nice DuckDuckGo alternative is Quant. A search engine that values you as a user, not as a product. Okay, I like it. I think I'm gonna roll with DuckDuckGo just because I can use it in my address bar, but I'll remember that. Thank you very much for the recommendation. All right, I think we have what we want. Back to get the coffee one last time. Be right back. Coffee has been acquired. Life is good. Hello, Justin. Good to see you. What's up, party people? Good morning. How are we? We are doing well. Thank you for stopping by the stream this morning. It's very nice of you. We are slowly but surely trying to fumble our way through a C program. We have figured out how to read and write to a file, which is a awesome thing. What was I in the middle of doing? Just got out of the gym, did hot yoga today. Nice. Getting some breakfast. Dude, that's awesome, dude. You're having yourself a kick-ass morning. Gym, breakfast, maybe there's some coffee in there. Let's go. I'm about ready to kick ass and take names. Oh, we were looking for constants. Yeah, constants. That's what we were doing. So remove this guy. And go here to the top. Got some pecan coffee. I like it. Pecan or pecan, I guess depends on how far south you go. So let's do hashtag define in C constant. Yeah. Pecan. Pecan coffee feels like some uber southerner shit. It does. I had some pecan coffee. Let's see, constants in C. How do you here's a free CoCamp article. I love free CoCamp. How to use define to define constants. In C, one of the common ways to define constants in C is to use the hashtag define preprocessor directive. This is exactly what I wanted. Minister of Defense, you are clutch. So this is what I want to do is I want to say memory size equals 496. Sorry, Steven, but it's pecan. That's totally fine. That's totally fine. I mean, in the Civil War, Kansas was a border state, right? So I think that in the Civil War, Kansas fought for the North. They were a free state, weren't they? So we should probably say pecan. Pecanin. Okay, then what else? What other constant can we add here? So there's a define. I guess start program start. I guess index. What would be the it? This is always going to start at 512. So the max size, right, is going to be if the number of bytes is greater than memory size minus this program start, we have an issue. This program is too large that we're trying to load into memory. So let's do, let's go up here and say program too large. Let's return program too large. And then we'll just give some feedback that says, file at exceeds max program size of %d. So this will be file path, and then let's go ahead and move this up and just give this a name. So we'll say int max program size. yank, put. Okay. So I think that's better. That's just another like defensive programming thing. I think what I'd like to do now is I'd like to try to read the. I think we don't want to be reading these in size of char. Or do we? Because char is 1 byte, right? Um, I guess what do we want to read these size of? Size of. Um, C. Reading binary file. What should be size of in fread? You can use assert macros, assert condition. Oh, that's a good idea. Let's see, C fread tutorial. Size of int. Reading until end of the file. Oh, this might be a better approach to reading the file. Oh no, because I want to know the size ahead of time, so I think seeking is actually useful. What is 1? Reading different data types. Hey, what's up? Nagon. Can't say. I don't know how to say your name. I don't want to say it wrong. Sorry if this has been mentioned already. How did you decide on this project? I just decided on it by Google searching. Um, I'm the main goal of my streams right now. Sorry, I kind of logged out there for a second. The main goal of my streams right now is to complete level 100 on boot.dev, and I need to build a project, and they really leave it really open-ended, so you can build really whatever you want. And so basically I just searched Google and was like, what are some good C projects? And this particular one kept coming up over and over again of people saying, you know, this would be a good way if you're new to C or you're new to doing anything with like systems level programming or emulation, that this would be a good place to start. So then I also like the fact that it has a visual component to it because I am on stream. I like the fact that eventually we're going to get the payoff of actually seeing like a working program render. So that's how I chose it. Whether or not I stick with it, or if I get frustrated and then admit defeat, I'll probably end up sticking with it. I just might crash out on stream a few times between beginning and finishing it. Okay, we want to use binary. And I guess we just want to read 1 byte at a time, right? That's basically what we're doing. So size of char works, but I think we could just do 1, right? Good morning, Bob Knoll. Long time no see. Thank you very much for sticking around my channel and being a member, man. I really appreciate that. I know I took some time off and haven't been as consistent, but I appreciate you. Yeah, Bob Knoll's here. where's my C++ reference? This is freed. I don't have permission to that resource. What are you talking about? I just want to search. What the hell? Read documentation. Size of each object in bytes. So I'm just going to declare that we're going to say each object is a byte. Yeah, we're just going to say each object is a byte. And let's make sure everything still works. So that still works. Now if I try to load the binary file. Hey, thanks for being a member, Gunheist. That's really kind of you. Honestly, can't tell you how much I appreciate that. It's very kind. If you don't crash out a few times while deving a project, it's probably not a project worth building. I absolutely love that attitude. So that prints nothing, or did it? Oh, I guess right here we should probably just print something that says like file loaded. File loaded successfully. File path. File loaded successfully, and then we print it. Now obviously okay. So obviously there's nothing, it's binary data, I guess. So if we try to print it as a string, that's not going to work. So how do we print binary data to the terminal? It's another question. C, print binary data to the terminal. I just realized something. I forgot to update my Twitch title to match my YouTube one. So I guess that's okay. I'm gonna leave it at that. It's fine. See how to do printf. There's a Stack Overflow. Printf doesn't directly support that. Instead, you have to make your own function. Something like while in, and then you do a bitwise to determine if it's 1 or 0. I guess what I want to get to is I want to basically print each of the 16 bits, right? So basically every 2 bytes I want to print that out so we can see it. Because the specification says, what does it say? Display, where's the instructions? Here we go. All instructions are 2 bytes long, right? So I basically want to read the file, and I want to read the file, and now I want to print all the instructions, but I want to print it some way that I can see like 2 bytes, 2 bytes, 2 bytes. That's what I'd like to have happen. Also, we can check some stuff off our list here. Print file contents, we figured out how to do that. Although I guess we're still kind of on it. We did figure out how to store contents of file in memory. So we're kind of right here. This is what we're trying to do now. So how do we parse the the 2 bytes at a time and then print those instructions. I wonder. Let's just do this. If we do, don't free it yet. I wonder if we say for int 0 equals, sorry, for int I, print f %x. Oh, that's a good idea. Okay, so let's try that. Let's just try dumping it as hex. Real quick. And see what happens. Oh, because this is going to print the first one, right? I guess because we have a... I wonder what that does print. I guess the first one. So let's try to loop over it. Let's try to say print line instructions. And then let's say for int I equals 0, while I is less than what was the constant I defined? Memory size. And I plus plus. We will print line.
Did we just become best friends?
Hey, Antonia. Thank you very much for following the channel. It's very kind of you. Would you give me the chip's memory at I? And we want to print X based on what Bob recommended. Now let's see what happens if we do that. So that's our hex. We have a bunch of empty. Oh, that probably makes sense because we're not. What are we loading? Oh, nice. Okay, that's it. Yeah, that's what I'm looking for. So now let's try to not print with the new line. Let's just try to print F. And let's just put a little bit of space. Yep, that's what we're looking for. Now, I think the one problem we have right now is we're putting the program at the wrong spot in memory. So we're actually reading it into the beginning, I think, of the memory, and it really needs to start at, if we're looking at the spec, it really has to start at, what was it, 512, I think is where it said to start. Yeah, so we really need to put it here. Excuse me, I don't know how to do that though. Fread C start specific place and destination buffer. It's so funny that half of figuring out what you half of getting an answer is figuring out how to articulate articulating well what you want. Guys, you need to shift your pointer buffer. I think I know what you mean, but I don't know how to actually translate that into meaningful action. Fan, I'm currently building a custom file dialog with AI for personal use. It's nowhere near one-shotting it, but I've been slowly improving it. Oh, cool. Very cool. Custom file dialog, huh? What's the use case there? Is that like when you upload a file and how your OS has like a default like window or dialog and you're trying to like overwrite that? Okay, so you're saying so I read I so you're saying it's okay that I'm reading it all into memory here. You're saying I need another operation after this that shifts that does something to this chip's memory, that the memory array to move everything? Is that what you're saying? Yeah, okay. Yep. That makes sense. Um okay, fs read. Fs read places bytes at beginning of destination buffer. Need to shift to 5. Need to shift
Did we just become best
5,
friends?
12. Hey, thanks for the sub, Light Demon. I appreciate that. It's very kind of you. Oh shoot, that's Node. Oh, and that's not fs read, it's f read. Okay, the signal you're looking for is supposed to be at the first 4 bytes of the file. That means it will not be located somewhere within a block of 512 bytes, but only at the first 4 bytes of it. There's no need to loop. This may be helpful. Maybe fread isn't the best solution for this. Maybe there's a better way to go about doing this. I know I need to move where the memory is currently sitting. See, when in my program, I click save and a window pops up that lets me browse the file system, select a place to save it, or when I need to select a directory, etc. That's what I'm making custom for my program. The reason is mostly learning and also because the one built into Windows is slow on my machine. So I thought to myself, I wonder what it takes to make one myself. That's cool. That sounds very interesting. Yeah. That seems like it's actually kind of a challenging thing because I built a file, an editor, basically like a little notepad tool in Rust. I would use fseek and move the pointer to exact position. I don't think that'll work because it's basically I just want to move the bytes of my program so that they start at a particular spot in my memory buffer, right? So I don't think fseek will work for that. Obviously, that's based on my limited understanding. But like right now, where am I? Why does that keep? Oh, I don't have Power Toys open, sorry. I was like, why is that not working? So right now I have, my program is loaded like this. And I really need to shift it so that it's sitting like this. What the heck? Why is this? There we go. So I need my program to be here. It's currently here. So how do I shift it? I mean, obviously I could just like create a temporary buffer and then write to the memory buffer. Like I could create a temporary buffer to hold the file and then loop over that temporary buffer. Or I guess loop over the memory buffer starting at the 5/12th index and start writing the other buffer there. But that doesn't seem elegant. Don't loop, use pointers only. Yeah, that doesn't seem elegant. Hold on. Before we go down, I'm gonna give myself a little bit of dopamine. I'm gonna mark because we did figure out this. We did figure this out. So I guess now the next to do is make sure program occupies correct space in chip memory. That's currently what we're trying to get done. Hello, Antonia. I appreciate you waiting the 10 minutes until you could chat. I apologize that I have that limit on there, but I've just taken the approach that I don't want people like spamming my chat or like drive-by chatting. So far, what I have working is the tree view of the file system with lazy loading. Nice. That seems to work really well so far. I'm missing the search and also things like directory watching. Let's see. And by directory watching, I mean like if a file changed outside my program in the directory I'm currently looking in. Excuse my English, I'm not native. No, your English is great. Your English is wonderful. I've understood everything you've written, so you should not feel self-conscious at all about your English. That sounds amazing, and honestly, it's amazing because if somebody asked me to build that, I wouldn't even know where to start. So that's very cool. Yeah, I understand. No worries. How am I doing? I'm doing good. That's a very, very kind of you to ask for that to be your first message. Yeah, I'm doing well. Let's see. Then first thing you should do is take CH-8 file size, like file seek. Yes, so I have the size of the file. Then assessing ROM size with ftel, I guess. So I do have the size of the file in bytes. That's something I'm already doing. So now I just need to figure out what is the right way to move that buffer of bytes to another buffer of bytes, but make sure that it's placed in the right spot. What are you doing? So I've been going through this kind of game. I'm calling it a game, but it's kind of a learning program called boot.dev. And one of the steps in their coursework is you have to build a portfolio project. You have to build a couple of them, but I'm at the point where you have to build your first one. And they really they leave it pretty open-ended to like what you build and what you want to do. And so I've never done anything really in C, and we just got done taking a course going over C. So we're trying to build what's essentially an emulator for running CHIP-8 programs, which are programs that were designed to run on like an old small micro chip, and we're basically trying to build an emulator that will run those programs but use C to do it. So basically like an interpreter of CHIP-8 programs. So you can, the cool thing is those programs can be graphically displayed, and like you can have obviously like logo, like the really common one is the IBM logo. But then there's also like games that can be loaded in and ran, which is pretty cool. Or I think it's pretty cool. It's nerdy, but I think it's pretty cool. Man, is it really almost 8 o'clock already? That's crazy. Time goes fast. Okay, fs read. Specify start position of destination buffer. God, I keep typing fs read. It's f read, dude. It's f read, Steven. It's f read. Oh, this sounds exactly like what I need. So this is your address space. LOC is from where you want to write to address space. I think this is exactly what I want. I'm pretty sure this is what I want. So can I just can I just do this? Can I just do, can I just do this? I know this seems super, I don't know if this is correct, but can I just do program start? Like that? Does that seem crazy? How long are we working on it? We just started today, so we're like 3 hours into it. What language do I usually write in? I usually work in C#, TypeScript, Go. I've been working a lot on a lot of side projects recently. I've been working a lot in Rust, which has been kind of fun. I'm terrible at it, but it's been a lot of fun. And C, I've been writing for like 3 days. 3 whole days, if you can believe it. All right, let's go back to printing this then. Let's print this here. Let's set I there. %D. %D. And let's try to run that and see what happens. Okay, it blew up. Why did it blow up? Oh, because this should be I. Passing argument 1 of fread makes pointer from integer without a cast. So what if I do like what they did in that example where I just say size of chip memory at 1 or at 0? If I do that. Passing argument 1 makes pointer from integer without a cast. Don't think I know what that means. I do know that this can actually, I can actually just make this explicitly u int 8t. Oh, address. That's a good idea. So this would be here, this address. So basically, we should make sure that it's 0. Okay, that didn't work. Okay, so what have I done wrong? Because it looks like it still stuck it. I guess I was hoping I wouldn't see it show up until we got to... Oh, maybe that is right. I guess I don't know what it should look like. You know what I mean? I don't know what it should look like if it's loaded correctly. So if we do this, what does this do? How does this differ? Does it differ? Yeah, it did something because you can see 512 is 0. And we have yeah, so it definitely did something. I don't understand the why when we offset it, it almost looked like there was stuff at the beginning. Maybe that's how it's supposed to be? I guess I won't know until I start actually trying to interpret it. Yeah, I don't know what this is. And I don't know where those are coming from. And also, .512 is the start of most CHIP-8 programs. Delete size of num of bytes. So you're saying try going back to the way I had it. I think that should be effectively the same thing though, shouldn't it? Yeah, I think it's effectively the same thing because this is just fread just takes have I dev any games? I have not devved any games before. I built a snake on the I built a snake game. But that's in the browser, but that's about as close to I've ever gotten. Maybe it's not up anymore. That's the only game I've ever built. Game dev, unlike a lot of people, has just never really it's not that it hasn't interested me, it just hasn't motivated me or inspired me in a meaningful way. Oh, there we go. This will probably take a long time to start because it's hosted on an Azure free app plan, so it'll probably take a little while to start. I think one and size of one in that fs read statement are effectively the same thing, or not fs read, fread. because size is the size of each object in bytes. So if I put 1 byte or size of uint8t, I think it's the same thing. Oh man, that's a long cold start. Print line size of u8 and t. This is present zu, right? Probably don't need to print out all those instructions anymore, Stephen. Yeah, size of uint is 1. So it's effectively the same thing. Because 8 bits is a byte. So I'm going to go back to doing this. It makes it a little bit more explicit of what I'm doing. And I'm just going to assume that that's correct. Yeah, I'm going to assume that it's correct at this point. So we have now accomplished, I think, this one, right? So now what we need to do is, I guess at this point, we'd actually start trying to turn this into actual instructions. Which I think I need to go read the spec to figure that out. Okay, we have some registers. Oh wait, you forgot to F close? Let me look. So before... So here I should close it. F close. F close. Okay. Closes the given file stream. Any unwritten buffered data are flushed to OS. Any unread buffered data are discarded. Whether or not the operation succeeds, the stream is no longer associated with the file, and the buffer allocated by setBuff or setVBuff, if any, is also disassociated and deallocated if automatic allocation was used. The behavior is undefined if the value of the pointer is used after fclose returns. So we just call it and pass the pointer right there. Okay. So since we already loaded it into memory, we can call it here. Give our file pointer, and now we can move on with our life. Good catch. Whoa, blood still going. Stack Overflow. I would say it's a throwback, but it's before my time. Yeah, we're still going. I actually have to probably stop here in like 10-ish minutes and go to work. I think we made good progress though today. We learned a lot about working with files in C, particularly just kind of your basics of how to read them, how to seek through them, how to tell how many bytes they have in them, how to read the file into a buffer in memory, which is good. We learned how to print the file contents. We've been able to get the individual instructions and print those as hexadecimal. So I think next is we need to parse. Okay, so I think actually this is not done yet, is it? So we probably need this is what we need. So parse individual instructions from binary CHIP-8 file. And then we basically have to break it apart into the individual pieces that the spec says. I think the spec breaks it down. Where is it? The spec breaks it down right here. So there's 36 different instructions. Each instruction is 2 bytes. and it's made up of these variables. I guess where does the opcode come from? So add x, y. Values of x and vy are added together. If the result is greater than 8 bits, vf is set to 1, otherwise 0. Only the lowest 8 bits of the result are kept and stored in the vx register. So we have to go through and basically, once we've got the instruction parsed, we have to then go through and do all these things. So that there's also some other things we have to do in here. So I'm going to add to do, parse instructions. We're going to have some additional stuff we need to do here to do add additional members, i.e. we need some registers. I think there's other stuff that we're going to need to add, but I know for sure we're going to need an XY register. So far, I haven't felt too overwhelmed. I still don't think I know what I'm doing or understand what I'm doing quite yet, but I think I have the rough outlines. Yeah. Oh, and also, D, just to go back to the Stack Overflow comment you made, the reason I'm doing that is really just to try to make it just a complete true learning experience, because this CHIP-8 thing is so pervasive. Like, so many people have done it and wrote about it and shared their code that I think if I search for things like it, the LLM's basically just going to dump the answer out in front of me, and then that kind of defeats the point of like doing it, right? It's like, well, the only reason you're doing it is to learn, and if someone just gives you the answer, well, you didn't learn anything. So I'm trying to force myself to go back to how like I would have originally, right, built something or learned something, right, and trying to avoid using AI in a way that may rob me of the learning opportunity. Rough outlines. I think I have a rough outline. Oh, here's the snake on the web game. It finally loaded. It took a long time to load, but this is the game I built. This was in 2022. This was 4 years ago now. Sheesh. It's a little laggy because obviously it's running on a loop, but it does work, and you can have multiple players. The camera's kind of obscuring the screen. I wonder if you could program this in CHIP-8. I bet you could, right? Honestly, don't know. I mean, if you can program Space Invaders, I would think you could program this. We should play games on stream, shouldn't we? We need to have some gaming streams. Those would probably happen at night, though, and not in the morning. Okay, I feel good about this. Let's go ahead and push up my code, and we'll just kind of make progress as we go. So we have main.ps. We don't need. Let's go ahead and add a get ignore. This would be, please don't commit any binary files.
My contribution to Steven's Tradcoder fits.
D, first of all, that is entirely too generous, man. Thank you very much. And I would be happy to use it to contribute to my Tradcoder fit. So let's go ahead and delete that. And in this, instead of doing out here, can we out it to bin. Let's add it to this. We'll just put it in there. That. And we'll just ignore bin. Oh, it won't create it, huh? So I have to make it. It's fine. No such file or directory. Oh, maybe you can't do it that way. GCC output into directory. I don't honestly know how to do that. You're welcome, man. We need more inspiring trad. Well, I appreciate that. I don't know if I'm an inspiring trad coder, but I do have a heck of a lot of time. Sorry, a heck of a lot of fun spending time doing this stuff. Now let's try. There we go. That's what I wanted. So we have git ignore, we have our main.c file, we have our test files. I don't think we need to commit our test files, do we? Yeah, that seems unnecessary. So we'll just also ignore test files like that. The docs. These are all available. This is actually not very helpful. That's the spec. These are our to-dos. Yeah, that sounds good. Let's go ahead and just say, actually, let's do this. Let's do git ignore. Chip. This is a CHIP-8 emulator that I built, that I am building as a portfolio project for boot.dev. Okay. And then let's go ahead and generate a license real quick because we try to be good citizens. License generator. Let's call this just chip. So we've got git ignore. Let's just do that as our initial commit. Sure, initial commit. And then let's do this. We'll say feature open and load file into memory. That's basically what we've gotten to. And then let's go ahead and go to our, let's do t repo create. And we have to specify name, so I'll do t repo create, and we'll call it chip. No git t login detected. Yes. Steven driven development. That's exactly what this is called. event-driven development. And then we'll do git add remote. Just change this to chip. Oh, this is backwards. And then I'll just go ahead and this is something that I've done a part of my workflow now is I'm just going to go ahead and create a repository on GitHub. It's basically the same name, and I'm just going to mirror the, nope, don't need that, don't need that, don't need that. Yes, go ahead and add it as a public repository. Do not need to clone it. So then we'll come over to our browser, and we're going to set up basically what I've been doing is I've been hosting all my code on my own Git server, but then I've been mirroring it to GitHub because I think most people probably are going to go to look for things on GitHub, right? Not that anybody really cares about my about my CHIP-8 emulator, but so then what I'll do is I'll go here and I'll go to settings and then I'll go to GitHub. And basically set up what they call a push mirror. So we'll copy our Git URL. And we'll come down here and we'll say, I'm going to push there, our username. And then we'll get our, shit, I thought I heard someone say my name. Get our PAT token, copy that, paste that there. We'll just synchronize it. So now it should show up over here. I switched to using Git. I switched to using Git just because then I can back my Git server with my own NAS. And so then all my code, all my repositories, I have confidence that I have them and they're backed up and they're safe and good. And then I sort of use GitHub just as a kind of the public, like where I would have guessed people would actually find the work I'm doing. And it also kind of acts as a secondary, I guess, a secondary backup of code. But I just got kind of worried at one point that what would happen if I did lose GitHub or if GitHub went away, like all my code is on GitHub, right? And so I was like, that doesn't feel good because there's some code that I've written that I care about, and I don't want to lose it to some unfortunate circumstance. Let's be CHIP-8 C. So like C programming language, boot dev, boot.dev. Is that a thing? What else? I think that's good enough. We'll make it pretty once we actually get something working. Alrighty. Well, it's 8:20. I've overstayed my welcome. I have to go get ready for work. I see I always GitLab on my own server. Far more options. Totally fair. Totally fair. Yeah, I landed on Git after looking at a couple different options. People had recommended GitLab. Git is what I settled on for now. And if it's the only drawback right now about Git is their CLI isn't the greatest. It's not or at least their CLI doesn't have all the same features as GitHub CLI. So I've had to change my workflow a little bit from that perspective. But for the most part, I've been happy with it. No complaints. All right, I'm off. I'll be back tomorrow. This is what we're gonna do for the foreseeable future. So if you're not interested in this, I totally understand. We'll be back to doing the other boot.dev stuff as soon as I finish this project. They said I should spend 20 to 40 hours on it. So my hope is it only takes us, I don't know, 4 or 5 days, but we'll we'll see if that's actually the case. Yeah, we'll see. All right, GitHub CLI is great. It is really good. They have a really good CLI. I'm very interested. I just need to wake up earlier. No worries, no worries. Yeah, I'll be here. If you're not here, that's no big deal. You can always watch the streams on the VODs on the YouTube channel if you want to catch up with what happened. And I probably will try to make kind of a recap video for YouTube once I finish this and just kind of explain what I did and how I did it and what I learned and whatnot. So even if you can't make it to all the streams, I'll try to have a nice succinct overview video at some point. See you guys. See you, Bob. Go Nutu. Sorry, I think I said your name right. I apologize if I didn't say it right. Bad timing. You showed up and I'm leaving. I apologize, but I hope you have a wonderful. What is it? Tuesday? Yeah, I hope you have a wonderful Tuesday, and I'll see you guys tomorrow morning. Okay, bye. Bye, everybody. Have a good day. Thanks for hanging out. Appreciate you.